Alright guys, so we were just going over the Pythagorean theorem. We said the Pythagorean says if we have a right triangle where A and B are the legs and C is a hypotenuse, then A squared plus B squared equals C squared. Now the question is, what if we don't have a right triangle? Can we still use the Pythagorean theorem?
No.
Unfortunately not, but however, there is a version of it we can use. Any guesses what that's called?
Law.
Yay, it's the law of cosines. And that's what we're actually going to do today, is we're going to talk about how to use the law of cosines here. So for example, if I have this triangle right here.
Where is that?
This isn't in your notes, this just watch me. Could I use the Pythagorean theorem here?
Yes.
Because it's a right triangle. Could I use the Pythagorean theorem here?
That's no. I guess not.
It's an obtuse triangle, it's not a right triangle, so I can't do the Pythagorean theorem. But mathematicians figured out a way around this. And there's actually an activity I could do to show you how they came up with this, but my guess is most of you don't care. But if you do care, come talk to me after school, I'll show you. And they came up with the law of cosines. Now the law of cosines can be written three ways, and you're going to know how to choose it depending on what you're solving for, okay? But notice, look at just this first part right here. A squared plus B squared equals C squared. Doesn't that look like the Pythagorean theorem?
Yes.
But now I have to add on this little adjustment piece because it's not a right triangle. I could use this, I could set it up for any of the legs. So I could say B squared equals A squared plus C squared, but then I have to modify it. Same, I could do A squared equals B squared plus C squared, but then I'd have to add on that modification. Alright, so now what I'm going to do, guys, is I'm going to write them here because we're going to refer to those all throughout the day. By the way, if it's lowercase, what does that mean it's referring to?
The side.
A side in the triangle. What if it's uppercase?
The angle.
Good job. Okay, now a couple of things to notice here. If I start with A, then I only use it here and I use the angle there. Everything else is the other two sides. If I start with B, then I don't see B again until the angle. If I start with C, I don't see it again until the angle. Okay? Do you need to memorize these formulas?
Yes.
The answer is no, you do not.
Well, it doesn't look that hard to remember.
You're probably going to memorize it just by using it enough. You'll be like, oh, I got it. But you are allowed to use your notes on the quizzes and tests, okay? All right, now there's really going to be two instances where we can use this. We can use it if we're given a side angle side combination. We can use it to find the other side. So if I know two sides and the angle between them, then I can find the other side. And that's actually the easy one. If we're given all of the sides, then we can use the law of cosines to find a missing angle. Takes a little more work, but it still is helpful. We can find it. Why don't we go through
Any missing angle?
any missing angle? Yeah. Because there's going to be three of them, right? Now, the law of cosines works great with the law of sines too. However, some of you guys didn't do your homework and don't know what the law of sines is, so you need to go back and watch that. So we're only going to use the law of cosines today.
You can't cheat.
All right. If you did it, you can still use that. I'm okay with that. Okay, let's look at number one. Y'all with me here? Am I given side angle side, or am I given side 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 here?
Side.
Yeah, do you see right here? I've got a side, two sides, and the angle between them. So I have, here's the side, and here's the angle between them. We call that a side angle side combination, right? Give me sass. Don't worry, my 7-year-old daughter gives me plenty of sass. So side angle side, great. What that means is that I can now solve for the other side. Now, when I'm looking at this formula, I see three versions. I see an A squared, a B squared, and a C squared. I want to find this missing side right here. What would we call this side? What is its name?
Hypotenuse. C squared.
It is not the hypotenuse because that's
B.
only for
it's
its.
B.
It is B. So Mindy, why is this side called B?
It's across from angle B.
Good job. So one of the first things you need to realize is that angle A is going to, if it's right here, then this is side A across from it. So A is 23. If this is angle C here, then across from it is going to be side C. So C is 20. And what that tells us is that we are trying to solve for B. Now, just any guesses out there, which formula am I going to use if we're solving for B?
The B one?
The one that starts with the B. Does that make sense? You're solving for B, so use this one. So what I do is I just write out the general formula. And it might take a little bit for you to get used to it.
This one's, is this one on our notes?
Yeah, this is in your notes.
I'm like looking at the assignment, that's why I'm so confused.
All right, so we're going to copy down this second formula because it's already solved for B. And that's what we're trying to solve for here. Okay, now what I'm going to do is I'm going to rewrite this, but instead of A, I'm going to put 23.
Instead of C, you're going to put 20, and then for B, we have 190.
There we go. So let's take a second and write this in. We're going nice and slow here. Now notice A is going to be squared, so I'm going to put in 23 squared. C is 20, I go up with that. And I have minus 2 times A is 23. B is going to be 20. And then I'm going to put in cosine of angle B, which is 119 degrees. Are you guys okay with how I have that so far? I just replaced A with its side, which is 23, C with its side, which is 20, again, A and C, and angle B with 119 degrees. Now, this is the nice part about when you're solving for a side is I'm just going to put that whole thing in my calculator. But before I do, you always need to get in the habit of checking your mode. Because if radians and degrees, if you're in the wrong mode, you'll get it wrong. So does everyone know where to go to check their mode?
Yes.
What mode should you be in? Any guesses?
Degree?
Yeah, since this is 119 degrees, you want your mode to be in degrees. So if you guys will go, make sure you're in degrees, and then I want you to plug in this whole big, long, ugly thing. And that should give you B squared. So plug that in on your calculator, and then turn to your neighbor and see if they get the same big, long, ugly thing, okay?
Is it all about parentheses like the other one?
Well, this one, the only parentheses you need around is the angle, the cosine of 119. So be careful with that, but everything else is pretty straightforward. So plug that in, check with your neighbor if they got the same thing. Melissa, will you tell me what you got?
I got, I'll look at that, but I got 1,375.02.
Can I just stop there? 1375.02. Is there someone who can confirm that?
Yes.
That's what you guys got too? Great. Is that my answer?
No.
That's B squared. And I don't want B squared, I just want plain old B. So how do you get rid of a squared? Alright, so what I want you guys to do is to take the square root of 1375.02. And we'll see if that number makes sense. Our two of the sides were 20 and 23, and this is going to be longer than those. What did you guys get when you took the square root?
37.08.
37, and it sends around to the nearest tenth, so maybe 0.1. Do you guys agree with that?
And it's definitely longer than the other two sides.
So that seems to make sense. All right, that is how you find a missing side using the law of cosines. We just plugged it into the formula. That gave us b squared, and we took the square root in order to get rid of the square. Pretty easy, right? All right, now I'm going to suggest something to you guys. Instead of getting hung up with the A, B's, and C's here, let's look at number 2. A problem people have with number 2 is they're like, which formula to use? There's no A, B, or C. What I would do is start thinking of this as side, and angles, right? So if I'm trying to find x here, let me write it out on here. Could I give E, D, and F new names for like A, B, and C? Sure. But I'm actually going to write it like this. I'm going to say x squared is going to be equal to, in the side angle side, we're going to do a side squared plus the other side squared minus 2, multiply the sides together, and then do the cosine of the angle. I'll put theta, because we don't know what it is. This is kind of a more general formula. It doesn't use A, B, and C, but that way you don't have to rename everything. And I think this will help you get through this a little bit faster. All right, so looking at number 2, do we have a side angle side combination there, guys? Which would be, do I have 2 sides and the angle between those 2 sides?
Yes.
Does that look like a side angle side?
Yes.
Awesome. Okay. So since I have a side angle side, I'm going to use 35.2 for one side, 31.7 for another side, and 49 degrees is going to be my angle theta. And those are going to be what I plug in. If you want to give them A, B, C names and choose one of those, great, but it'll be the same thing. All right, so Antonio, will you help me out on this one? What was one of my sides? So I'm going to say x squared is 35.2 squared. What was the other side? Okay. And then I need to subtract 2 times those sides, so I have 2 times 35.2 and 31.7. And lastly, I need to remember to do the cosine of that angle. What was the angle, Antonio? Awesome. Does that make sense, guys, how we can plug that in, even though we didn't have names for A, B, and C? That we just know we're solving for that opposite side, so just put the information in like that. Okay, now put that in your calculator. Square root. This one's a little harder because of the decimals, but you got a calculator doing it for you, so that's nice. All right. Brian, what did you get on this one for x squared? You guys agree with that?
I got a huge number out of though.
That's what I got. I got 779.8 as well. So make sure you subtract the 2 times 35.2 and make sure you're good. Make sure you're in degrees as well. Can someone else besides me and Brian confirm that? Did anyone else get 779.8? Awesome. So then what do I still need to do here? Because I'm not done. That's what x squared is. So we're going to square root. Go in my calculator and I'm going to square root that guy. I got 27.9. You guys agree with that?
Where are you getting these numbers from? I'm not really-
I'll look at it with you here in a second. Now, just looking at our triangle, does that seem to make sense? If this side is 31.7, that side is 35.2. It looks like this is the smallest angle, so that would give us a smaller side. Does 27.9 seem to make sense there?
Yes.
Yeah. I mean, we're not going to like get out a ruler and measure anything, but we're just getting an idea. Okay, now that is how you're going to do the first 4 problems on your assignment. So I'm going to give you 5 minutes now to get started on your assignment. So, will you,
Oh, there we go.
do you see the one, it's a CUDA assignment? What you're going to do is you're going to follow these examples and try to get 2 or 3 of these done, okay? So, let me pause.